Multimeter tutorial part 2. In this part we learn about other quantities like current and AC voltage. Okay, we have a circuit here with a DC battery connected through a 1 kilo ohm resistor to light up an LED. Okay, first we connect the battery to show the circuit is working and the LED is actually lit. Now, to measure the current, we set the mode to current. Our current range here is milliamps, so we set it to milliamps. Then we select the milliamps port for the red probe. For the black probe, which is the common in current measurement mode, the multimeter must be in series with the component. So I can't put this across the resistor, although I could get the voltage across it using Ohm's law and divide it by R. But our goal here is to measure the current. To measure the current through this resistor, we need to disconnect one of the lead, either component of, and connect it to a new rod. Now, for simplicity, I'll disconnect this lead from the battery, or rather disconnect the battery from this lead. You can see the battery is no longer in this column. It's positive terminal and the LED turn off. Now, the new column I create, I connect one multimeter probe to the previous column and the other probe connects here. The multimeter is now in series with the resistor. As you can see, current is flowing in the circuit. The multimeter has a very small internal resistance in current mode, so it doesn't affect the circuit. So in this state, the multimeter is in series with the resistor. Yes, you can see the current here. Okay, now we want to test the diode with the multimeter. Here, we connect the red probe to the desired part. We connect the red probe here because the diode symbol is clearly marked here. We place it on the dial, set to the diode mode. The negative terminal is marked here, the one with the silver band. Connect the black probe to the negative terminal and the red probe to the positive terminal. I should even about 0.6 volts, as you can see here. So the diode is healthy. Another variable we want to measure is the effective or RMS voltage, in fact AC. Here we place the probe here, the AC voltage. This is the negative terminal of the rotary switch. The AC voltage marked here with sine wave. There is no positive or negative anymore. You can in fact place it wherever you want. As you can see, a voltage of approximately 225 volts RMS or effective. Measure it. If we swap the positive and negative terminals, it still has no effect on the measurement because AC voltage has no positive or negative. Note that this value is not the maximum value, but the effective value that has been measured, which is related to the maximum value according to the relationship specified here. Okay, we now want to measure capacitance. We set the rotary switch to capacitance. Here we must use a module that is on the multimeter. Some multimeters have a capacitance meter on the screen itself. This type of multimeter requires an external capacitance meter to be attached. Well, here is the capacitor symbol. It should be placed between these two pins, and we place it here. This is the positive terminal for the negative terminal. If the capacitors are attached, they don't have positive or negative, like this capacitor, whose value is also written on it, meaning 220 nanofarads. Okay, I can put this on these two terminals and see its value, about 217 approximately nanofarads. So you see it measured our capacitor. Now if the capacitor is electrolyte, which has positive and negative, it's marked on the side. The negative is marked. The negative should be placed on the left. Okay, here you see the capacitor's value, 98 microfarads. So in this way we can measure capacitors, provided the multimeter has this capability. Now we want to measure hFE or bed-test transistor. So we set it to a certain reading. We must use this module. It's clear that it should be between these two terminals. In fact, if you look closely, this is the NPN transistor, collector, base, and emitter, and PNP on the right side. I'm using an NPN transistor model BC107, which usually has a beta of 300 to 350 for the transistor. If we look at its pin from above, this pin with the notch is emitter. When turned to the right from above, it's the collector, and the next one is in this way we can identify the transistor. So I placed it here according to the pinout I have taught you, and you can see its beta is 346. Its hFE is measured for this type transistor. It's possible that those BC107s might be slightly different from other BC107 in the market, depending on the company and manufacturer.